Lesson 94, page 389, dependent, independent variables, functions, and functional notation. All right, welcome to the fun and exciting world of where algebra is going to take you. Functions, functional notation, independent and dependent variables are going to be a very, very big deal when you get into college algebra and calculus. So if you're moving in that direction, this would be a lesson that would be good to have figured out. My teachers in high school never did very well at helping me figure this out, and I hated functions, didn't get them, didn't know what in the world it meant. So hopefully I can help avoid that terror in your life, and you will get them. So, dependent variable. You guys heard of these before? Okay, for all intents and purposes, we're going to call our x and our y values those names. When you're given an equation like y equals 2x plus 4, what are we solving there? For the x or the y? Who said both?
I did.
Thank you. We're solving for both, but it says y equals. So it appears like we're solving just for y. Okay. Does it matter what the x, what number we put in there for x? Can I put any number I want in there? Yeah, I can put any number I want in there. Let's say I put 1 in there. If I put 1 in there, what's my y?
6.
Okay, so if I put any number I want in there for x, the answer I get is completely independent, or the number I put in for x is completely independent. It means it's not worried about anybody. It can be any number it wants to be. So the x value is normally your independent variable. It's any number you want.
It's dependent on.
But the y, thank you, is dependent on what you choose for your x. So you chose 1 to be your x. Does y have a choice on what it is? No, because it's 2 times 1 plus 4 equals 6. It doesn't have a choice there. So that's really... Now you can change those so that y becomes your independent variable and your x becomes your dependent variable, but that doesn't happen very often. 99% of the time it will be y equals 2x plus 4, not x equals 2y plus 4. So for the most part, that's all you're going to have to worry about. It's just knowing independent is x, dependent is y.
Not all it is for dependent and
Are we done?
No. All right, page 390, 94b, functions. Okay, let's put up the y equals 2x plus 4. If x is 1, what's my y value? If my x is 2, what's my y value? If my x is 3, what's my y value? Okay? So if I put in a number for x, it's going to kick out a y value. Those of you, none of you did, because the last time I taught 7th grade math was when my seniors were in 7th grade.
Yeah, Mr. Dell. Oh, I think we Mr. Tomaso.
For 7th grade math?
Interesting.
he can hear you too well.
We had to teach him.
Yeah, this is like art class.
Hey, I remember that.
Yeah, Darlene remembers that.
Yeah.
This is my function machine. And I can name my function machine anything I want. In this particular case, I named it y equals 2x plus 4.
That's a cool one. Check it out.
when I stick a 1 in my function machine, it's going to spit out
6.
a 6. Okay?
I'm not drawing.
Hmm?
I'm not drawing.
So that's what functions do, guys. Function machine says you put in a number for x into the machine, you plug it in for x, and it's going to spit out a y. Okay?
You taught this in 7th grade?
Yeah. If you're continuing on in math, we're going to make a few changes, and we're not going to call that number or that letter y anymore. Okay? Sometimes we will. Sometimes we'll call it a y. But another thing that we do is instead of a y, we call it the function of x. It looks like that. F with a parenthesis with an x. It's the same thing as y. It means the same thing. But what it says here is what happens to this problem when we put a 1 in. So what this would look like is a I would not write this whole table here. I would just do this. F of 1. That means what happens when I put a 1 in that function machine? What's it going to spit out? So f of 1 equals 6. What happens when I put a 2 in for x? Or a 3 in for x? So you will see that symbolism there from now on. All that means is, what am I going to get for y when I put a 3 in for x? That's all that means. So not
So
two-
f of 3 is...
f of 3 would be
10.
2 times 3 plus 4. Yeah. Just take the number, stick it in the equation, whatever it spits out is your answer for f of 3.
So f of 3 is the x value.
The 3 is the x value.
Yeah.
Yeah. All the time when you're doing this. If I gave you a g of x or a g of 3, it just means the same thing. They'll give you they'll use a bunch of different letters. They all mean the same thing. They don't have to have f for function. It could be g for function or h or j. I mean, it doesn't necessarily represent the first letter of the word function. Okay, so let's talk about functions here for a little bit. What they be and what they not be. Okay. Okay, so let's look at functions. Functions, for the most part in math, are going to move from left to right or right to left. So, sorry, graphs are going to move left to right or right to left. You get all kinds of graphs. Some are going to be functions, and some are not. Okay? So an important thing to know about functions is, if we're drawing a graph, and let's do some numbering here. What point is, well, let's give me a horizontal or vertical. What point is that? What point is this?
3, 2.
Okay, and this one? 5, 3. Okay. What do the x's have in common with each other? They're 2 away, but really there's really nothing in common. You know, they're not like the same or the same number in, positive and negative. They're not opposite in sign or anything. They're just random x's, random y's, and just happen to be every other one. I mean, you just start putting all your points up here, and there's really nothing in common. If I were to dang it. If I were to graph this point, those 3 points,
It would all be at 1.
I'd be at 1, 3,
1, 3, 1, 2.
1, 2, and 1, 1. Okay, that's a problem. Your x values have to go to a y value that's different. Okay? So, for every value of x, there can be only one value of y. So up there, how many value? What is my value of x?
1.
1. So here's my value of x. And the rule says, in order to be a function, it can only go to one value of y. How many values of y did it go to? 3. So it's not a function. Okay? So whenever you have a vertical line in your graph where your x values are the same but your y's are different, it's not a function because you can't have more than one y value. Okay? In math, in math, I've heard it, I thought I made it up, but I was talking to another teacher that's taken a class with me, and they use the same thing. It's kind of like two-timing when you're dating. Okay? So let's say that the x value is Elias.
Or 3
Kristen
times.
said something.
Okay?
Everybody's
So,
looking for me.
Elias is a player here. He has 3 different girlfriends.
They can't be
He
the same.
can't do that. Okay? The x value, Elias, sorry, but you cannot be dating 3 different girls.
I the player hit the game.
And let me tell you why, Elias.
Good out there.
It has to do with functioning. You cannot function day to day dating 3 girls. It will drive you crazy. You won't get any sleep. You'll run out of money. You'll get caught, and 2 of them will kill you. Well, 3 of them will kill you. So, I've already tried it. Been there, done
So
that.
good at math.
So, functions. Your x value cannot go to several different y values. So, if I were to ask you or give you different options about whether something is a function. So, I give you these points.
No.
Is that a function?
No.
No, because 2 of my x values are the same. So if I give you a list of coordinates like that, all you have to do is look at the x values. If they repeat themselves, it's not a function. If I give you something like this, and I put in the number 4, the number 3, and the number 3 over here, and when I put 4 in the function machine, it spits out a 3. When I put a 3 in the function machine, it spits out a 3. Is that a function?
No.
Think about it. Let's write out the coordinates. What are the coordinates for this one?
4, 3.
What are the coordinates for the other one?
3, 3.
Do the x values repeat? No, they're a function. Okay. It doesn't matter if if the y values are the same. We don't care about the y values. All we care about is the x values. X values cannot be the same.
So the girls, the Y's can cheat with the X's.
The girls can cheat, but the guys can't. Exactly. Yeah.
Something fair.
It's not fair, but you know, that's just the way society functions. All right, so whenever you have one value related to another value, or whenever you have one value matching another value, you have what is called a relation. Okay? It doesn't matter if it's a function or not. As long as you have an x value and it gives you a y value, there's a relation. A function is a relation that only has the first value going with the y value. Okay. So, last thing I want to go over, and then we'll be done, is domain and range. Okay. Domain. D comes before R, X comes before Y. So that usually helps. What that means is, when we have our XY axis here, and I've got a graph here, and I'm only interested in the numbers between 3 and 8. Okay? I don't care what's out here. I only care about what's in between here. That's called the domain. The x values that I'm concerned about for my answer. So it's like, okay, the domain is the numbers between my x values here that I'm concerned about.
Is it always that?
Always that. My range is if I'm only interested in the numbers here. And let's say this is 1 and this is 3. My range is going to be the numbers vertically that I'm interested in, my y values. Okay? So domain is the left to right, the horizontal, the x numbers I'm interested in. The range is, the range is the y values I'm interested in. Okay? And I think that's it for that lesson. But don't forget functions, because we will be doing it for the rest of your life.